Hey everybody, welcome back to Algebra 2 with Mrs. Gunn. Today we're talking about Chapter 7.5, Quotients of Rational Expressions. So a radical expression is not simplified if there is a radical in the denominator. That's a big no-no. You can't leave a radical in the denominator. So we do something called rationalizing the denominator. And what we're doing is we look at what it would take to get a whole exponent in the denominator. So for example, if I rewrote 2 over the square root of 3, that would be 2 divided by 3 to the 1/2 power. So I need a whole number here. So I'm going to multiply times 3 to the 1/2 over 3 to the 1/2. Because when I multiply these together, that's going to give me 2 times 3 to the 1/2 over 3 to the first power, because you add the fractional parts of the exponents, which would be 2 times the square root of 3 over 3. This is a rationalized denominator. We're not allowed to have a radical in the denominator. It can be in the numerator, that's fine, but not in the denominator. So you have to look at what you could multiply by to make the exponent in the bottom a whole number. Okay? Let's see, let's do another. What if I had 5 over the cube root of 5? Well, that's the same thing as 5 over 5 to the 1/3 power. I need to multiply this by something so that I have a whole number exponent in the bottom, not a fraction. So I'm going to multiply it times 5 to the 2/3 over 5 to the 2/3. That way, when I multiply these denominators together, I've got 5 to the first power. Okay, but now look at this. I've got a 5 and a 5 in the top and the bottom, so I can cancel those. My final answer is 5 to the 2/3 power, which is the cube root of 5 squared, or the cube root of 25. Okay, how about this one? So this is 2 times 3 to the 1/2 power. So I'm going to need to multiply this times 3 to the 1/2 power over 3 to the 1/2 power. Because when I multiply these two together, I'm going to get 3 to the first power. So this is 8 minus, and I can write the square root of 3 as 3 to the 1/2 power, over 2 times 3 to the 1/2, and times 3 to the 1/2 is 3 to the first power. But I am going to have to distribute here. Okay, so 8 times 3 to the 1/2 minus 3 to the 1/2 times 3 to the 1/2 is just 3. And then the bottom is 6. Well, that's going to simplify to 8 square roots of 3 minus 3 over 6. You can't cancel the 3 and the 6 right here because you would have to factor out a 3 first from this binomial and then cancel, and you can't factor out a 3 here. So there's nothing to cancel. This is your final answer. And your calculator, if you bought the calculator that I have recommended to you, will actually change this expression for you. It'll rationalize it for you, but you still have to know how to do it without the calculator, but you can use the calculator to check. Let's do another one. Now when you have something like this, and if you can reduce the fraction inside, go ahead and reduce the fraction inside. So this is the cube root of 1/6. Okay, but now we can break this apart. That's the same thing as the cube root of 1 over the cube root of 6. But we can't have a root, a radical, in the denominator. Okay, so the cube root of 1 is just 1. But that cube root of 6 is the same thing as 6 to the 1/3 power. I'm going to need to multiply it times 6 to the 2/3 power over 6 to the 2/3 power, which is just 1. But this way, when I multiply these denominators together, I'm going to get 6 to the first power. So 6 to the 2/3 over 6. And I can rewrite that as the cube root of 6 squared over 6, which is the cube root of 36 over 6. This is a correct answer. You can't leave it with a radical in the denominator. How about this one? The square root of 1/6. Well, I can't reduce the fraction, so I'm going to rewrite this as the square root of 1 over the square root of 6. And 6 is 6 to the 1/2. The square root of 6 is 6 to the 1/2. So sometimes it's easier, I think, if you multiply. When you're doing square roots, it's just easier to leave it with a radical instead of a fractional exponent. But you can change it to 6 to the 1/2 and then multiply times 6 to the 1/2 over 6 to the 1/2. Either way. Okay, so the square root of 1 times the square root of 6, well, that's just 1 times the square root of 6. But the square root of 6 times the square root of 6 is 6. So there's your answer. How about the fourth root of 6/18? Well, 6/18 can reduce to the fourth root of 1/3. So let's break that apart. The fourth root of 1 over the fourth root of 3. But the fourth root of 1 is just 1. Okay, so when I'm dealing with these weird roots that are not square roots, I like to change them to fractional exponents. 1 over 3 to the 4th, because that makes it easier for me to see that what I have to multiply by is 3 to the 3/4 over 3 to the 3/4. Because my fractions, when I multiply, these fractions have to make a 1 for an exponent. Okay, so that's going to give me 3 to the 3/4 over 3 to the first power. So I can rewrite 3 to the 3/4 as the fourth root of 3 cubed. And in the bottom I just have 3. And the fourth root of 3 cubed is the fourth root of 27 over 3. So that is my answer rationalized. Sometimes we have a binomial in the denominator, and the way that you rationalize this is to do something called multiply by the conjugate. And here's how you find the conjugate. If you have a binomial here with a minus, the conjugate is going to be the same numbers with a plus. And we're going to multiply by 1 in the form of the conjugate over the conjugate, like this. What's going to happen is it's going to make these radicals disappear. But now, in order to do this, we're going to have to distribute here, and we're going to have to FOIL the bottoms. Okay, so the top, let's write it all out so that we don't make a mistake. 2 square roots of 5 times the square root of 7 plus 2 square roots of 5 times the square root of 15 over, on the bottom, let's FOIL. The square root of 7 times the square root of 7 plus outer square root of 7 times the square root of 15 inner plus a negative square root of 15 times the square root of 7, and then last plus a negative square root of 15 times the square root of 15. Okay. Excuse me. So we know we can combine what's under the radical. We can go ahead and multiply. So this would be 2 times the square root of 5 times 7 under the radical, 35, plus 2 times the square root of 5 times the square root of 15 would be 2 times the square root of 5 times 15 is 75 over. Now what do we have on the bottom? The square root of 7 times the square root of 7 is 7. The square root of 7 times the square root of 15 would be the square root of 105. Here we have the negative square root of 15 times the square root of 7 is the negative square root of 105. And the last one, the negative square root of 15 times the positive square root of 15 is minus 15. Now see what happens? On the bottom, positive square root of 105, negative square root of 105 cancel. So we just have to see what we can simplify now. So now I have 2 times the square root of 35 minus 2 times the square root of 75 over 7 minus 15. Well, I can still do a little bit of simplifying here. The square root of 75 I can simplify. I can't simplify the square root of 35 because that's just 7 times 5. But 75 has a 5 squared in there I can take out. I could say that's 25 times 3. That was sloppy. And 7 minus 15 is negative 8. Okay, the square root of 25 I can take out, that's a 5. So that's going to give me 2 times the square root of 35 minus 2 times 5 times the square root of 3 over a negative 8. So that's 2 times the square root of 35 minus 10 times the square root of 3 over, I'm going to put the negative out here, 8. And I can reduce that by dividing out a 2 and canceling. So that's negative 2 times the square root of 35 minus 5 square roots of 3 over 2 times 4. Cancel those 2's, and I get, for my final answer, I'm going to write it up here, negative square root of 35 minus 5 square roots of 3 over 4. Which truthfully, we should probably distribute that negative in the top. So we could also say that's the same thing as negative square root of 35. Oops, hang on, I see a mistake here. I went from a plus 2 square roots of 75 to a minus 2 square roots of 75 right there. So that's a boo-boo. That should be a plus. 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 And then when we distribute that negative, it's going to make a negative right here, because this was a plus. That's a plus. Over 4. So either way is the same. Okay? So your answer may vary slightly from what's in the book if there's a negative involved. All right, let's take a look at this one. So when we have this binomial with radicals in the denominator, we're going to multiply by the conjugate. The conjugate is the square root of 5 plus the square root of 3 over the square root of 5 plus the square root of 3. So we're going to FOIL the top and we're going to FOIL the bottom. So to FOIL the top, the square root of 5 times the square root of 5 plus outer, the square root of 5 times the square root of 3 plus the inner, the square root of 3 times the square root of 5 plus the last, square root of 3 times the square root of 3 over, let's FOIL the bottom, the square root of 5 times the square root of 5. Outer, the square root of 5 times the square root of 3 Enter negative square root of 3 times the square root of 5. And last, negative square root of 3 times the square root of 3. I want to make sure it's clear that that's a positive. I mean a negative right there. There. Okay. So the top, the square root of 5 times the square root of 5 is 5. The square root of 5 times the square root of 3 is the square root of 15. Here's another square root of 15. And here is a 3 over. Here's a 5 plus the square root of 15 minus the square root of 15, and then this is minus 3. So you can see these two cancel out. That's the whole purpose of multiplying by the conjugate. We get rid of the radicals in the denominator. So what do we have here? 5 plus 3 is 8, plus 2 square roots of 15 over 5 minus 3 is 2, but we can factor out a 2. And that's going to cancel those 2's, and it's just going to leave us 4 plus the square root of 15. And the square root of 15 I can't simplify, so there's my final answer. And believe it or not, if you type this into your calculator as a fraction, it will rationalize it and change it to 4 plus the square root of 15 for you. But you still have to show your work, so you have to know how to do it. Okay, so here's another binomial with a radical, so we're going to multiply by the conjugate. The conjugate is the square root of 5 plus 6 over the square root of 5 plus 6. Okay, that's 1. The conjugate is the square root of 5 plus 6. So let's multiply. Here we have to distribute. So 8 square roots of 5 plus 8 times 6 over. We have to FOIL the bottom. The square root of 5 times the square root of 5 is just 5. Outer, the square root of 5 times 6 is 6 square roots of 5. Inner, negative 6 times the square root of 5 is negative 6 square roots of 5. And last, negative 6 times 6 is negative 36. See how these cancel? Alright, so we have 8 square roots of 5 minus 48 over 5 minus 36 is negative 31. And you can leave it like that, or you could factor out a negative 1 in the front. Okay, it just depends on what variation of answer you have in the book. But it's fine with me if you leave it like that. Okay, here's another one. To simplify it, we want to multiply by the conjugate. So we're going to multiply by the square root of 3 plus the square root of 2 over the square root of 3 plus the square root of 2. So for the top, FOIL. First, 2 times the square root of 3. Outer, 2 times the square root of 2. Inner, the square root of 7 times the square root of 3 is the square root of 21. Last, the square root of 7 times the square root of 2 is the square root of 14. Over, on the bottom, the square root of 3 times the square root of 3 is 3. Outer, the square root of 3 times the square root of 2 is the square root of 6. Inner, negative square root of 2 times the square root of 3 is negative square root of 6. Last, negative square root of 2 times the positive square root of 2 is negative 2. Now these are going to cancel. So we're left with 2 square roots of 3 plus 2 square roots of 2 plus the square root of 21 plus the square root of 14 all over 3 minus 2 is 1. So this is the answer. The whole point of multiplying by the conjugate is that we get rid of the radicals in the denominator. What about something like this? What would you do? Well, the trick is to rationalize each denominator first and then try to add them. So what we're going to do is we're going to say 10 over the square root of 10 minus the square root of 5, and go ahead and multiply by its conjugate. The square root of 10 plus the square root of 5 over the square root of 10 plus the square root of 5. Then I can say plus this guy, 8 over the square root of 2. What do I need to multiply that by? The square root of 2 over the square root of 2. Okay, so now I need to distribute on the top right here. 10 times the square root of 10 plus 10 times the square root of 5. I have to FOIL the bottom here. The square root of 10 times the square root of 10 is 10. Outer, the square root of 10 times the square root of 5 is the square root of 50. Inner, negative square root of 5 times the square root of 10 is negative square root of 50. And the last, negative square root of 5 times the square root of 5 is negative 5. Over here, this becomes 8 square roots of 2 over 2. Okay, so let's see what we've got now. 10 square roots of 10 plus 10 square roots of 5 over, these two cancel, and I have 10 minus 5 is 5. This guy's going to reduce. 2 goes into 2 once, 2 goes into 8 4 times. So he becomes 4 square roots of 2. And this we can reduce too, because you see how I could divide a 5 out? So this would be 5 times 2 square roots of 10 plus 2 square roots of 5 over 5. So those are going to cancel. Bring down the plus the 4 square roots of 2. So my final answer is going to be 2 square roots of 10 plus 2 square roots of 5 plus 4 square roots of 2. And that's it. There you go. Okay, so this one is number 23 from the homework. I thought I'd do it on here because you guys are probably going to be asking me how to do it. So let's see, how can we do this? Well, the first thing I would do is I would prime factor these guys. Okay, so let's prime factor 80. Well, that's 2 times 40, and then 2 times 20, and then 2 times 10, and then 2 times 5. So we have 2 to the 4th times 5. So let's go over here. 2 to the 4th times 5. Now 8 to the x, let's prime factor that. 8 is 2 cubed to the x. And the bottom we have, oh, we should change 4. 4 is 2 squared to the x power. Okay, so now let's see what that gives us. That gives us 2 to the 4th times 5. But when you have 2 to the 3 to the x power, that's the same as 2 to the 3x power. And on the bottom, 2 squared to the x power is the same as 2 to the 2x power. You see where I'm going here? Okay. So look what's left. Now check this out. When you're dividing, you can subtract the exponents, right? So if I have 2 to the 2x here and 2 to the 3x here, that's 3x minus 2x. So I can rewrite that as 2 to the 4th power times 5 times 2 to the 3x minus 2x. And that gets rid of what's in the bottom. So that's 2 to the 4th times 5 times 2 to the x, because 3x minus 2x is x. Now here I have 2 to the 4th and 2 to the x. Well, when you have the same base and different exponents, what do you do to the exponents? You add them. So 2 to the x plus 4 times 5. Or you could write it as 5 times 2 to the x plus 4 power. Either way is correct. So that's how you do number 23 on the homework. I think that's enough to get you going, so give it a shot and I'll see you soon. Bye.